Okay, here are the solutions to the first mole worksheet, Introduction to the Mole. I'm going to read this thing in its entirety, so I don't bore you too much. I'll read the paragraphs rather quickly, and I'll focus on the answers. Here we go. Chemists use the mole all the time to figure out how many atoms or molecules are in a substance. The mole is an amount, 6 times 10 to the 23rd, right? The mole is a number, and it's easy to measure. It's also known as Avogadro's number. More importantly, the average atomic mass in grams for each element has exactly 1 mole of carbons. For example, a mole of carbon has a mass of 12.01 grams, and those 12.01 grams contain 6 times 10 to the 23rd atoms of carbon. We can say that the molar mass of carbon is 12.011 grams per mole. If I only needed half a mole of carbon, no problem. I'd just divide that in half. That sounds like about 6 grams of carbon. And instead of 6 times 10 to the 23rd, divide it in 2 in your calculator, and you'll see you get 3 times 10 to the 23rd atoms of carbon. Similarly, 24 grams of carbon, well, that's twice the 12. That's 2 moles of carbon. It has 1.2 times 10 to the 24th atoms. You can try to do these in your head, or you can just plug them into your calculator. Here's an example. What's the molar mass of water? How many molecules would it contain? So imagine water in a glass, and let's check it out. Well, water is H2O. We can find its molar mass by adding up the average atomic masses, and here it is fairly precisely 1.008. Technically rounds to 1.01 to 3 significant figures, but anyhow, about 1 gram per mole times 2 for the two H's, 16 grams per mole, 18 grams of mole roughly is a mole of water. And since this is a mole of water, those 18 grams contain a mole's worth. Always remember that the mole is a number, Avogadro's number. So that's how many water molecules you would have. Okay, let's go ahead and solve some problems. You got a mole of aluminum. How many grams of aluminum would that be? Look it up on your periodic table. You'd see that it is 26.98 grams of aluminum. How many atoms does it have? Well, it's a mole's worth, and the mole is a number, so it's 6 times 10 to the 23rd atoms of aluminum. Notice the difference between what it weighs and how many there are. If I needed 2 moles of aluminum, note the 4 significant figures. I'd mass out 2 times 26.98 equals 53.96 grams of aluminum, and recognize that since it's 2 moles, it contains 2 times Avogadro's number. Punch that in, you'll see it's 1.2 times 10 to the 24th aluminum atoms. Note the 4 significant figures. Wonderful. I got some TNT. There it is. 1, 2, 3 nitro groups, so trinitro. Benzene with a methyl group is called toluene, trinitrotoluene. Let's figure out its molar mass. I got 7 carbons, that's 84, 5 makes 87, add the rest, and you should get 227 grams per mole for TNT. But if you only had 1/10 of a mole, what's that mass? Well, that should be easy. The mass of that is 22.7 grams. But how many molecules do you have? Well, 1/10 of Avogadro's number, not 6 times 10 to the 23, but 6 times 10 to the 22. What's the lightest element? I'm thinking hydrogen. If you have a molecule of this element, what's its molar mass? Ooh, be careful here. Don't say 1 gram per mole, because a molecule lets you know that H is not necessarily H when it's like stable. It bonds to itself and it forms H2, so we're going to say 2 grams per mole. Determine the molar mass of triethylamine. Well, those of you who are familiar with these skeletal formulas know that N's or Ben's are carbon. So I have 2, 4, 6 carbon atoms. Each one of these has some implied hydrogens based on the honk rule that carbon always forms 4 bonds and hydrogens are implied. Since I only see 1 bond there, I see 3 there. 2 bonds there means 2 hydrogens there. I'm thinking C6H15N. Add them up. 72 plus 5 plus 14 is 101 grams per mole. You'll normally see this as 101.13 due to the added precision that you see on the periodic table. but I hope you get the idea. Okay, that is Mole Worksheet 1.1, Introduction to the Mole.